We are given the table values for f of x, g of x, f prime of x, g prime of x, and we have to find the two questions in part A and part B. That is, we have to find h prime of 1 and h prime of 2. This part B, we have the uppercase h prime of 2. So let's do the part A first. We have been given h of x equals f of g of x. So basically, this is a composition of functions f and g. This is a composition of f and g. So when we find the derivative of a composition of functions, we have to apply the chain rule. So let me do that here. Derivative of h of x is written as h prime of x. So here we find the derivative of the composition of this function f and g. So which means we have to first find the derivative of the f function, which is basically f prime. And since it is f of g of x, we write down this as f prime of g of x. Now we have to apply the chain rule to find the derivative of g of x, which is g prime of x. So let me write down this as g prime of x. So basically the derivative of h of x, which is a composition of f and g, is f prime of g of x multiplied with the g prime of x. Now we can find the h prime of 1. So I'm going to plug in x equal to 1 into this equation, or I replace the x's as 1. So therefore I get h prime of 1 equals f prime of g of 1 multiplied with g prime of 1. Now we can get all these values, that is g prime of 1, g of 1, everything is available from the table. So let's pull it from the table and substitute it over here. So I'm going to write down this as f prime of, we have to first find g of 1 from the table. So here we have this function g of x, and this is at x equal to 1. So therefore g of 1 is 2. So I'm going to replace 2 over here, and then we have to find g prime of 1. So basically we look at this column to find the g prime of 1. So, and the row is the first row, which is 1 here, that is x equal to 1. So the g prime of 1 is 6. So I'm going to replace this as 6. Now we have f prime of 2 multiplied with 6. So we have to find the f prime of 2 from the table. So we basically look at this column at x equal to 2. So, and then we have to look at the second row. So this means 5 is the value, that is f prime of 2 is 5. So I replace this quantity by 5, and we already have the number 6. So this gives 5 times of 6 is 30. And this means the answer for h prime of 1 is 30. So let me write down 30 as the answer over here. Let's do the part B. So here we are given the uppercase h of x is given as g of f of x. So once again, this is a composition of two functions, g and f. So let's find the derivative. The derivative of uppercase h of x is h prime of x. And we have to find the derivative of this composition of function, that is g of f of x. So first we have to find the derivative of the g function, which is g prime of the function inside, that is f of x. And then when we have to apply the chain rule to find the derivative of f of x, which is f prime of x. So I write down this as f prime of x. Now since we have to find h prime of 2, we replace x by 2 into this equation. So therefore this becomes h prime of 2 equals g prime of f of 2 multiplied with f prime of 2. And we can pull out these values from the table. So I'm going to first find out f of 2. So I basically look at this column, that is f of x column, and x equal to 2, and this is the second row. So the value is 1. So I can replace this f of 2 as 1, that is this becomes g prime of 1, and we have to find f prime of 2. So I'm going to look at this f prime of x, at x equal to 2. So 5 is the f prime of 2. So I put 5 here. And now we have to find g prime of 1, which means we have to look at the g prime of x column. The input is x equal to 1, but we have to look at the first row. So therefore, g prime of 1 is 6. So I replace 6 over here, and we already have 5. So 6 times of 5 is 30. So therefore, the answer to this part B question, and this also 30. That is h prime of 2 is 30.